We start lesson 2 with a discussion of something I've called natural center. You won't find the definition for natural center anywhere because it doesn't exist. I made it up. But it is something that you can feel. I think of it as something like love. You can't prove love, can't see love, but you can feel love. And that's going to be true of natural center. Anyway, f of x is the sine of x. If you were guessing the natural center of the sine of x, you might guess x equals 0. You'd be right. You feel it. See? You feel that? How about the cosine of x? The natural center is x equals 0. H of x equals e to the x, natural center, x equals 0. You just feel it. You feel it. Now, let's say we had p of x equals the sine of x minus pi over 3. Can you feel that? Can you feel the natural center? X equals pi over 3. Or h of x equals e to the x plus 4, natural center, x equals -4. So you might want to develop a definition for this. You might say, well, it's the thing, the quantity that makes the value of x that makes the quantity in parentheses equal to 0, and you'd be right there. But that doesn't always hold true. So let's say I had a j of x, and j of x is the natural log of x plus 1. The natural center here is x equals 0. That one you might not feel as much, but you will see why we say the natural center is 0 there. Now, f of x is cosine of x. I'm looking directly at the notes now. This is question number 1 of the notes. F of x is the cosine of x, and we'll say that the natural center, x equals 0. Then there are two parts to this. Part A says, write a fourth order Taylor polynomial for f of x is the cosine of x centered at x equals 0. Well, this is our natural center. And if I'm asked to construct a series about the natural center, that is my indication that I'm going to use some memorization. So the cosine of x is approximately the fourth order polynomial, which, as long as we have the cosine of x series memorized, we're good here. We just have to go up 4 orders. 1 minus x to the power of 2 over 2 factorial plus x to the power of 4 over 4 factorial. And I stop. No minus dot dot dot, because this is the fourth order. Order being the fourth derivative. Fourth derivative was 1, and that 1 is snuck in here, but we don't need to write it. Okay, so now question B says, write a third order Taylor polynomial for the same function, f of x is cosine of x, but this time centered at x equals pi over 4. That is not the natural center. So if I'm asked to write a series centered at a non-natural center, then I need to actually raw construct the power series. I can't just substitute into something that I know. So I'll need f at pi over 4. So that's going to be the cosine at pi over 4, which will be the square root of 2 over 2. I will then need the first order coefficient, f prime pi over 4, which is negative sine pi over 4, which is negative square root of 2 over 2. And then the second derivative of pi over 4 will be negative cosine of pi over 4, which will also be negative square root of 2 over 2. And finally, f triple prime pi over 4 equals positive sine pi over 4, which brings us back to positive radical 2 over 2. So my function, cosine of x, is approximately a third order polynomial which is equal to the square root of 2 over 2 minus the square root of 2 over 2 times x minus pi over 4, because I'm centering it at pi over 4, minus the square root of 2 over 2, x minus pi over 4 to the power of 2 over 2 factorial, I'm leaving this unsimplified, plus the square root of 2 over 2 times x minus pi over 4 to the power of 3 over 3 factorial. Done. I'm going to stop there. Example number 2, f of x is a different function. This time it is the cosine of x minus pi over 4. That has a different natural center, and the natural center here is x equals pi over 4. So now we go to question A, and question A says write a second order Taylor polynomial for this function centered at x equals 0. So 0 is not the natural center of this function, which means I have to raw construct to find the power series, or polynomial, to approximate the power series. So f of 0 I'll need, which is going to be the cosine of negative pi over 4, and that comes out to be still positive radical 2 over 2. F prime of 0 comes out to be negative sine of negative pi over 4, and that comes out to be positive square root of 2 over 2. And finally, because it wants a second order, f second prime of 0 is the negative cosine of negative pi over 4, which comes out to be negative square root of 2 over 2. So our function here, f of x, is approximately p2 of x. I don't need to indicate when I write that it's centered at 0, because when I write the terms out, it will express it as such. So my first one is going to be square root of 2 over 2 plus the square root of 2 over 2 times x alone. Then the next term is negative square root of 2 over 2 x squared over 2 factorial, unsimplified, but you see by the way that this is written, it implies centered at x equals 0. Now in part B, they say come up with a power series for the cosine of x minus pi over 4, but centered at x equals pi over 4. See here, because it follows the natural center, then we take something that we know, the cosine of x series, we know that series, and we simply plug in x minus 4, because a power series at 0 has certain properties. The cosine of x centered at 0 has certain properties, and this is the cosine of x minus pi over 4, but centered at a natural center, so I just need to plug it in. So the f of x is approximately p3 of x, which equals, now I know the cosine starts off with a 1, and then it goes minus, but I'll write x minus pi over 4, I'm using substitution, squared over 2 factorial, plus quantity x minus pi over 4 to the 4th over 4 factorial, and I meant to say 4th order here, a 4th order polynomial. So there it is, and we could go on forever if it's at its natural center, because we've got the power series memorized. Next example, number 3, part A wants us to come up with a, let's see, a third order Taylor polynomial for this function here. F of x is e to the 5x centered at x equals 0. So I come up first and say, well, what is the natural center? And the natural center of this function, x equals 0. So that's good. That makes me happy in part A, because it's natural center. I can just substitute into a series I already know. So f of x is approximately p, what did I say here, p3 of x, which equals, the power series for e to the x goes 1 plus, but I'm substituting now the 5x instead of x, plus 5x squared over 2 factorial plus 5x to the power of 3 over 3 factorial. Stop. That is a third order Taylor polynomial for e to the 5x centered at x equals 0. So part B, center at x equals 1. That is not the natural center. Sad face, because I have to do more work. I have to raw construct. So I'll say f of 0, not f of 0, but f of 1. I'll say f of 1 is e to the 5. F prime of 1 comes out to be 5 e to the 5, and we're doing a third order, so I got to go 3 derivatives. Second derivative of 1 is 25 e to the 5, and the third one will be 125 e to the 5. Those become the coefficients. Not too bad of a raw construction. So f of x is approximately P3 of x, this time centered at 1. So I have e to the 5 plus 5e to the 5 x minus 1 plus 25 e to the 5 x minus 1 squared over 2 factorial plus 125 e to the 5 x minus 1 to the power of 3 over 3 factorial. Last example, number 4, you might want to try this one on your own. F of x is e to the x minus 2, which has a natural center of x equals 2. The first part, A, says a third order Taylor polynomial centered at 0. That's a sad face, because that's not the natural center. So I'll need f of 0, which comes out to be e to the negative 2. I'll need f prime of 0, which is also e to the negative 2. F double prime, and f triple prime will both be e to the negative 2 power. Those are coefficients to a power series centered at 0. F of x, which is e to the x minus 2, is approximately P3 of x, which is equal to e to the negative 2 plus e to the negative 2x plus e to the negative 2x squared over 2 factorial plus e to the negative 2x to the power of 3 over 3 factorial. And B says give me a power series for e to the x minus 2 centered at 2. Happy face, natural center is 2, so I just need to substitute into e to the x. So f of x, which equals e to the x minus 2, is approximately, this one was also third order, P3 of x, which equals 1 plus x minus 2 plus x minus 2 squared over 2 factorial plus x minus 2 cubed over 3 factorial. When it's natural center, I can keep going on and on and on, and I can get more and more terms with ease. So here it is.